I'm in a series of introduction to our design project, and we're going over the phases in design. And last time I talked about schematic design, which we're not going to do, design development, which is what our little project will be, and not even completely, not the complete design development, but a lot of it. And finally, construction documents, we certainly will not be doing. Since we are not doing the schematic design, I would like to at least talk about it. So let's talk about structural schematic design. In a schematic design, you would do two things. You would list out the design criteria, and I've done that for this project, and I'll show you what I did. And you would come up with a structural concept, which I've also done, and is actually the starting point for your design development for this project. Design criteria. In the design criteria document, you essentially want to line out what the governing codes are, what design load criteria you are using, and any special considerations or requirements that will impact the project. In the structural concept, you'll list the materials you use and what type of framing system you will use. You'll do a preliminary framing layout. You'll have typical member sizes. So I've done that for you in this project. Your actual sizes might be different. And for typical members, you put their spacing. I've also done that for you. You would also locate the lateral system elements. Knowing that we were just going to design the I didn't really give this much thought, but I put it in there. The more I think about it, it's probably not correct. We need a few more shear walls in our building, but I didn't even think about it that hard because I knew we were only going to design the gravity loads. In this schematic design part of the project, you have certain deliverables. The two main things are a design report, where you list all the criteria, and in words, you describe the structural system. Some of the clients, they really can't understand drawings, others can understand drawings. So you have to write out in words what the structural system will be. And then you also provide schematic drawings. So you make sketches, hand sketches are fine, of the layout, and you locate the primary lateral elements. And again, I've not done a good job on that for this little project because I wasn't worrying about it. Let's talk about the structural design criteria. Typically, when you write this document, you write where the project's located, what building code it is, for example, 2006 IBC, or I think ours is 2012 IBC. You list all the load criteria, not the actual loads, but the input that goes into determining the loads for live, snow, wind, seismic, and any foundation design criteria. And what I've done is I've made a fictitious geotech report that you'll use for that. And then you propose the structural materials, like what's the F prime C and what's the grade of the steel you use. So you would have a location, something like this. Our project, I think, is in Lincoln, Nebraska. You would then go online with the city, and you'll find the building code that's been adopted. I made these slides some time ago. It'll probably be 2011 IBC or 12 IBC. Which it was, and every city amends the IBC with local things. For example, here in Laramie, I think the IBC has a snow load of 20 pounds per square foot, but the city has overwritten that to be 30 pounds per square foot. Here's says 2009, 2006. I'm sorry, our project is actually going to be 2012. And these are the chapters that are important to what we're doing. These are structural chapters. In chapter 16, which are the design chapter. It references ASCE 7, and IBC references a lot. It used to be that you could buy the IBC and have everything you need to know in it, but now it says, like in concrete, look at ACI 318. And I think the reason they did this was so that the people who authored the individual codes or model codes could make their money by selling their codes. Anyway, it references a chapter. It talks about general design requirements like occupancy category, deflection limits. It goes over loads and load combos. And the occupancy category, which is really important, it's basically 2 is normal, okay, and everything else is special. So low hazard buildings like storage facilities, anything that's holding a hazardous material, and the highest category, essential facilities like hospitals, fire stations, I believe police stations. These facilities must remain operational in all instances, and so they have their highest category. Our building will be category 2. Category 3, these hazardous buildings in 2009 had their own requirements. So anything that held more than 300 people, this is interesting. Primary schools with 250 or colleges and universities with 500. So you need 500 university students to trigger category 3, but only 250 elementary school students to trigger category 3. And I used to joke that means that elementary school students are worth twice as much as college students. But what it really has to do with is mobility. College students can move out, evacuate quicker, make better decisions. At least that's what I think it is. These things are social value judgments. And yeah. And then, okay, I2 facilities with 50 patients. And these are, and the reason I think that these numbers have to do with mobility is because of this. I2 facilities are people who cannot take care of themselves, are not mobile, as well as I3, they're not mobile, okay, like jails. And so 50 in I2, any kind of jail is a category 3, or any other building with 5,000 people or more, so like a hotel or something. Power generation facilities, water treatment facilities, etc. And so we're designing an outpatient office building. And so we will not have anybody, even though it's a medical facility, we don't have anybody like this. So you're going to be category 2. Live loads, they give a table with live loads, and you could look that up. Snow load criteria, that comes from ASCE 7. I'm not sure if it's chapter 7 anymore. Sorry, I should update this. The things you need to list are not the actual snow load calculations here. It's just the input that goes into the snow load calculation. So the ground snow load, exposure factor, thermal factor, importance factor. And if you've taken any basic structural engineering course, you should have gone over this on how to calculate snow loads. However, I must admit, as I went to university in Hawaii and I taught at LSU in Louisiana, I didn't really know anything about snow load criteria, although now I know a lot about snow load criteria living in Wyoming. Wind load criteria, again, you don't have to actually calculate the wind loads. In this document, you list the variables, so you can, they're handy, you can go find them. The basic wind speed off the map, and remember in 2011, the maps changed because the load factor changed down to 1.0, and so they had to basically change the wind speeds so that when you took v squared, but then you multiply by 1, you got the same loads. exposure category, topography factor, enclosure classification, importance factor. Again, if you've taken an elementary structural engineering course, you should know all about wind load calculation. The variables that go into that calculation go into this design criteria document. Seismic load criteria, this might actually not have been something you covered. There are lots of chapters in ASCE 7 that go over this. You can find the parameters you need for seismic load, at least in the US, on this USGS website. And the site class you need to also put in this document, and that's determined by a geotech. And you should get this, because otherwise you have to use a default of D, which is very bad and is probably not true. So you hire a geotech to determine the site class. You need an importance factor for the seismic load criteria, and you need these design acceleration parameters. And again, beyond the scope of this class, if you're taking structural dynamics, you'll learn about it. You use these parameters to develop what's called a design spectra. Yeah, I don't have time to go into this. I'll just sketch it real quick. So typically, you have these load spectra like this, and then you can actually construct these spectra if you have the earthquake record. And so in the Christchurch, the first earthquake in Christchurch, I can't remember what it looked like, but it looks something like this. They had a spectra that looked like that and like this. And so there are certain periods of, and this is the period of the structure, and this is spectral acceleration. Anyway, I'm just saying that these load spectra that you create from the code don't always work, but totally beyond the scope of this class, but super important for concrete structures. All the important, interesting things for concrete buildings have to do with lateral loads, specifically earthquake loads. The foundation design criteria that goes into this report are subsurface soil properties, specifically the bearing strength, which we'll use for the foundation design. Again, you hire a geotech engineer to determine this for you. If you don't have a report, which is a bad idea, you can use this table in IBC. And the local building code will specify minimum frost depth for your spread footings. And just so you remember, you put the bottom of the footing at this frost depth. Okay, let me show you an example of one of these. And so let's see, do I have it? Oh, I don't have it here. I just have an example, but not the one for our project. And so here's a design criteria example. This is for an office building in Cheyenne that I had a class of mine once designed. This actual building, if you go to there, you can see it. So these are all the things I told you about. The building code, the occupancy categories, the live loads, roof loads, wind load criteria. So these are all the variables that go into the wind load, the seismic load criteria, there they are. And then the foundation criteria, they're all in there. You also produce the structural materials. There you go, the reinforced concrete, masonry, structural steel. And here's a description in words of the framing system used in that project, which is different than the one we're doing. And there's the lateral load system and the foundation system. So these are just narrative descriptions of the three things you'll be designing. And for our class, we are only doing the gravity load. Okay, so I think that's enough of an introduction to schematic design. I'll stop there.